Hey, hope you had a good weekend. Mr. Hardy back here. No video today. I'm excited. Well, no video of my face today. This no haircut thing is getting a little out of control, but that's beyond the topic here. So what we're going to take a peek today is at something called radians and arc length. When we're talking about angles at any time, whether it's in geometry, algebra 2, or any time past then, we are going to start chatting about, I almost call it what we call a trig or a geometry language, radian. In speaking it's something different in degree. There's certain types of mathematical operations we're going to do that require us to have our angle measures in radians. Otherwise they don't work. So let's chat a little bit about that here first before we get into doing any actual geometry with it. So we're going to take these degree measures on the front here and we are going to convert them into radians. So it says right next to it, multiply by pi over 180. So here's how this looks. So 30 degrees, for instance, we're going to take 30 degrees and we're going to multiply it by pi over 180. Now, here's what we're looking at here. We're not going to plug in 3.14, okay? There is a pi button on most calculators. I'll show you the one on this one here too in a minute, but I don't even want to get into that in the calculator, and I'll show you why on that as well. What I typically do is I will take my degree measure, I'll put it over 1, because fractions times fractions is a lot easier than figuring out where does my 30 go. And I'm going to multiply straight across. Yes, that is my dog in the background, if you can hear her. She's fired up about something, I don't know what. So here's where our dilemma with the calculator can come into play at times. If I go to my calculator, and again, between your apps and other things like that, you should have some sort of a calculator similar to this point, I hope, but a regular scientific should work. And I went and I tried to type this in. So what would happen is I'd do 30. Again, I don't want to use decimals. On the TIs, the pi button, you can see the little pi symbol. No, probably not if I have the shadow of my finger over it. Here we go. Over here. So it'd be second, and this up arrow key, the caret key, would be pi. And then we divide by 180. Well, here's our dilemma. We get a decimal. Okay? Even if I do math enter, I get a decimal. That's not what we want. It says right up here, no decimals. Well, what do I do then? What I'm going to do instead is I'm going to take the coefficients there. Okay, I'm going to ignore pi for a minute. I'm going to treat it sort of like it's a variable instead of a number. And that 30 divided by 180 is what I'm going to put into my calculator and do math, enter, or whatever your fraction button is. It says 1/6. So my actual answer here would be 1 pi over 6, or I could just say pi over 6. Okay? And so that's how we can make this conversion. I know, it seems kind of strange, right? You're like, okay, why would I do this again? You're going to get to see that here momentarily, but I want to make sure we've got this part down on getting degrees into radians. So like it's the same every time. There's no little catch or no little exception that we can do. Not really. Every time it's just going to be take my degree measure, multiply by pi over 180. And again, it's important to show this, not just because Hardy says I need to show work to get credit, but you're seeing it as you're speaking it, as you're hearing it, and you're more likely to be remembering what's going on here. Multiply across, we got our helper. Again, just the coefficient part. Math, enter. Okay, so 5 over 3 this time. The pi always stays on top of our fraction. Okay, try not to write 5/3 pi. Technically, I know it's the same value, but we really want to be careful because when we're using this in the math problems, we want to see it in a fraction form, just like this. That's all the rest of this side is. Getting some practice at that, making sure you've got this down, reducing as far as you can. Okay? Now, when do we actually use this? Let me show you. on the back, okay, is actually using, where would I need to use radians, okay? We're going to find the length of the arc. We chatted a little bit about this last week, okay? The arc, again, is the outside. It's like the crust of our pizza that we have here, the crust of our pie, if you want to look at it that way. Find the length of the arc. It'll be the part that looks darker when it's one of these. Remember, if it's in degrees, change it to radians. Well, I was a little bit of a pud here. They're all in degrees, okay? We need to get used to doing this. So again, made a little note here. Change it to radians times pi over 180. So there's going to be 2 parts to each of these questions, okay? We might even stretch this into the whole week thing. So there's a lot of things you're getting practice with here. I'll make the later one in the week really short now because this is kind of long. So first part. Actually, we'll use green here instead. First part, turn your degree measure, 210 degrees, into radians. Otherwise, your answer is going to be way different than what you'll see on the key, or what you'd see in any key or quiz that you may see down the road. So 210 pi over 180, but again, I want to make sure, again, just the numbers, leave pi alone. Pi, we're just treating it like it's a variable. Enter, or your fraction button, whatever you happen to have. Okay, 7 over 6. 7 pi over 6. Now that's just part 1. Part 2, this is where we're actually going to find the length of the arc. Okay. So to do that, there is a formula for this. It's a very short formula. So to find the length of the arc, now I'm not quite sure why they decide to use the letter S here. It's kind of a curly S, but you know, it is what it is. But to find that arc length, it's just theta, okay, times the radius. You're like, okay, what's theta? We just found it. It's a fancy way mathematicians like to call for angle measures, okay? They tend to use Greek letters. This is what's called a Greek letter. It's also just like a circle with a line through it, kind of like a Pokemon ball or something, but you get the drift. So now, to get that answer, all I have to do is 7 pi over 6 times my radius, which is 7. And again, I'm just going to make fractions out of everything. Multiply across. No decimals is the rule. And I've got me an answer. Now, a couple reminders here as we go, and I'm looking for a quick piece of paper, which of course I can't find when I'm looking for one here. This will do the trick. Reminder, if you haven't yet gotten yourself one of the calculators, either on the computer or the phone, just a reminder of what some of those are. If you are doing Apple stuff, again, we've got a couple of good options. We've got Calculate, that's 84 there that we're working with. And we also have, Caitlin is going to bother me on this and say, Hardy, I've told you a million times. I think I put this in one of the emails, so don't quote me. I'm close, though. Calculator X, I think I got this. If we were live, maybe you could give me like the thumbs up here. And otherwise, if you're going computer, if you're going Android, I'm still working on finding another option. I've had a few people start to tell me that Wabbit is starting to have some issues. So I'm on the lookout for another one of those. So stay tuned. Hopefully in the next video or two here, I will have another one found. But I haven't found one that, has a lot of the same button presses that we do. Ooh, reminder. You'll have to look back in the emails on this too. I don't have it to put up on the screen right now. You also could check the past couple of emails from Mr. H if you haven't deleted them. I put a link in one of them TI, the people who actually makes these calculators, have given out a link to actually get the video, the online version of theirs there. So maybe you look to see, or if you've deleted that or something and you'd like me to resend it to you or find you the link, just shoot me an email and I'll be happy to do that for you. Okay, enough of the side stuff here. I will get back to my business at hand. So for 1 through 5, you see the arc, you see the information. You're like, well, what's different about 6 through 10? Not much, really. Okay, when we get down to 6 through 10, and I'll try to keep everything on the screen here, it's just now everything's right here for us. She's like, wait, it says theta, so can I just... No, that's not in radians. Oh, I don't know what's going on upstairs. Yoofda. So again, 2 parts. Degrees into radians first. Nice thing about this, again, you can pause me, you can rewind me, whatever you got to do to get her done here. At this point, you probably all got something somewhere on a calculator that will reduce this down for you. Now, I will say one thing here in a minute. So, ooh, that's not coming in real clear, is it? 5/6, for those of you at home. That's where we're all at, though. Is that I know there are a lot of apps out there that will do this stuff for you. You plug them in or you scan it with your phone. And you're like, woo, I got the answer. To get credit, I need to see work like this. I don't care if Wolfram Alpha can do it. I don't care if fill in the blank of your favorite app can do it. Okay, that's not going to help you long term. It's just the cheap way out. And we don't do things the cheap way. At least I hope not. And so finally with this one then, okay, our arc length, and yes, you may see it, radius times theta, theta times radius. The order doesn't matter, we get both of them in there. 5π/6 times my radius. Now again, no decimals, and we want to reduce as far as we can. So here, 5 times 8 is 40, 6 times 1 is 6. Now, would I tell you that you're wrong if you just left it that way? No, but if I do 40 divided by 6 with math enter, I do see, kind of, really blurry, 20/3. Let me help you out there. That it does go down a little bit more. So try some of these out. The keys are on the site as well for you to be able to see those along with the worksheets. I ended up having to do pictures of these because the PDF function for this program is not working right now. So we're gonna make do with as best as we can. But I'd like to hear from some of you. Shoot me this back with as much as you get through. Get some points. Again, grades can't go down. They definitely can go up. So I'm going to have a spot in Skyward where I can start putting these points in to start getting you some points for that. A couple of you have done that already. I'm going to get those in right now. And I look forward to hearing from a few more of you a little later this week. Have a good one.